All right, so quartiles, as mentioned in the anchor chart, are denoted with this Q sub 1, Q sub 2, and Q sub 3 that are divided into 4 equal parts. So, we have our minimum, we have our maximum, and then we have these 4 quartiles. So this is our median right here at our 50 percentile. Then we have our 25%, our 75%, and then our minimum and our maximum. And if we were to throw a box over that, we pretty much get a box plot. We have something called a 5-number summary. Notice we have our Q1, Q2, Q3, plus a max and a min, and that is called our 5-number summary. And so you'll see a lot of questions asking you to just figure out your 5-number summary for a selection of data. And then just some more vocab review here. We said that IQR is interquartile range, which is going to be our Q3 minus our Q1. And then this is what's going to help us find our outliers again. So there's a lot of repeat information, but it's at least here and written down if you don't have access to your anchor chart. So they want us to find our 5-number summary and the IQR for the given data sets and determine if they have any outliers. So I'm going to try to zoom in on this data set a little bit here and make sure that we have it all. So we need to find our min, our Q1, our Q2, Q3, and our max. So our min and our max are easy. Our min is 1 and our max is 15, right? And with a data set like this, we can always use the counting method because it's nice and small. So maybe I'll go in 3, 1, 2, 3, and then we can see that one more. So our middle, our median, our Q2 is going to be 9. And then if we want our Q1, that's going to be the median between your middle and your min. So we're going to repeat that process again. So here would be 1, 1, 1, 1. So 6 is our Q1. And then if I was going to repeat that process to find our Q3, that's the median of your median and your max. So you would just evenly make sure that you go in, and that one is going to be 10. The next thing we want to do is find our IQR. That interquartile range is just your Q3 minus your Q1. So in this case, that's 10 minus 6, which is 4. So if I want to search for an outlier on my lower boundary, I'm going to do 1.5 times 4, which is 6. And we subtract that from our Q1. So if Q1 was 6, right? 6 minus 6 would be 0. Do I have any points less than 0? No. So I have no outliers on the bottom. And then I would do my Q3, which is 10, and I'm going to add that 6, that 1.5 times 4, which is 16, and I do not have any values that are 16, so I have no outliers here. And that's the process. Now I'd love to see if you could figure out that same process for the second example here. Just my advice to you is I'm just going to highlight these so we know where they are. For our second example, definitely put them in order first. So that's going to be your first step. But I'm going to do that part, but do pause and see if you can figure this one out on your own. All right, so maybe you figure this out, maybe you unpause. Let's see how we did. We have 3, I put them in order. And so the first thing we know, we need to find our 5-number summary. So that's going to consist of our min, our Q1, our Q2, our Q3, and our max. And of course, we know right away that our min is 2 and our max is 10. And now I want to see if I can find my median. That's the one I always do next. So maybe I go in 2, and now I'm between 3 and 8. So remember, when that happens, you need to find the middle of the middle. So you can average them together. So 8 plus 3 is 11. 11 divided by 2 is going to be 5.5 for our middle. So now when we think about that, this is half. If we want the half of the half, that's going to be 2 and 9. See how that one's a little different because now we had an even data set? Good. I wonder how you did with that. Now we want to figure out our IQR, and our IQR is that inner quartile range between Q3 and Q1. So 9 minus 7, our IQR is 5. Oh, I don't know why I just said 5. That is hilarious. 9 minus 2. Oh, because I said 7. That's why. 9 minus 2, which is 7. Got ahead of myself there. All right, so to find our outliers, we would do 7 times 1.5, which is going to be 10.5. So to find our outliers, we take our Q1 and subtract 10.5. And we take our Q3 and add 10.5. And any number above this number or below this number would be an outlier. So in this case, we also had no outliers. Now, all of this information, these is called just finding your 5-number summary. But once we have our 5-number summary, it becomes very easy to draw our box plots. So a box plot, it can actually be defined as a graphical representation of a 5-number summary. And so we have all of the information we need. Here's some more information that if you'd like to read through, you should definitely do. But I'm going to touch upon a lot of those points as it is. So let's just go to our first example. This is the time in minutes that a student spent in the laundromat in a week for 15 randomly selected weeks as follows. And so we have all of this information here. So we need to do a lot of data before we can draw our box plot. So the first thing that we want to do is definitely put all of this information in order. So let's do that to the best that we can. My smallest number is 62. So maybe you want to say I find any other numbers in the 60s. 67. Look for the 70s, 72, 72. I saw a 73. 77. Now I think we have to graduate to the 80s. I have an 81. I see an 83 and an 84 and an 85. Then 90, 93, 107, 112, and 135. So that's always our first step, and it kind of has been all year with all of these data sets we've been working with. And we want to find our 5-number summary for that. So I'm going to just steal some space over here. We have our min. We need to find Q1, Q2, Q3, and our max. So min is really easy, and so is max. We have 62, and we have 135. If we want to find our middle, we would count in. So maybe I'll go like 5 data points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do another one, do another one, another one, and another one. We land at 83 for our median, which is also our Q2. And then once we find that, we are able to use our min and our median to find our Q1. So let's go 2 on each side. Another one, and it's somewhere in between 72 and 73, which has to be 72.5 is going to be the true middle there. And then we can do the same process on the other side. 1, 2, 1, 2, another one in between 90 and 93, which is going to be 91.5. Once we have our 5-number summary, we can draw our box plot. So I want to start by drawing myself a number line. This is my preferred method here. And I'm just going to go kind of count by tens to give myself kind of an idea of what's happening. So this is 60, 70, 80, 90, 100, 110, 120, 130, and we'll call that one 140. So 120 up. We started at 60, 70, 80, 90, 100, 110, 120, 130, 140. So this is not part of my box plot. This was just me doing a little pre-planning here. When I go to do my box plot, I'm going to start with my min. My min is at 62. So 62 is going to start here, just after 60. And I'm ending at 135, which would be about here. And that's the line that I'm going to draw for my box plot. So then if my Q2 is 83, that's going to be somewhere around here. And then my Q1 is 72.5, so we can eyeball that. And then 91.5, we can eyeball that. And I can turn that into my box. All right, so that's a really good place to start. Here we have our box and whisker plot. Is this skewed at all? There definitely is a little bit more space in here, and you can see we have a long tail, so this is skewed right. And then it's asking us, does it have any outliers? We have a formula now for outliers. We can't just say, oh, I think 135 is an outlier. So to find our outlier, we need our IQR, which remember is going to be 92.5 minus 72.5. Was it 92.5 or 91.5? Which is going to be just 19. So when we do 1.5 times our IQR, that's 19 times 1.5. Which is 28.5. And so we want to take our Q3 and add 28.5 to get 120. And we want to take our Q1 and subtract 28.5 to get 44. And so from this, we can see that 44 is not on our box plot, so we have no lower outliers, but 120 is. Anything in this range is an outlier. So do we have any values in that range? Well, 112 is small enough, but 135 is not. So yes, 135 is an outlier. And we found that mathematically, and that also explains why we have such a long tail. So that combines a lot of my tips about, now we've seen an example with an outlier, but definitely with how I kind of went through with that gray, that lighter color first. I always did like pencil pen when it was physically in class to see how we have a very clean number line, because even though these are the mins and the maxes of your data, not all of our box plots are going to be exactly the same and look super nice and pretty and normal, and so you want them to reflect the actual data that is there, including that skew. There's just one more concept that I wanted to go over with you guys today. There is this information sheet here for you that I'd like you to read through on your own time about how Boxplot can help us better see the distribution of data. So you can see how the normal distribution with our histograms corresponds to Boxplots. So a lot of times you'll see them next to each other, and how it can compare two data sets. That one's really important. So just please read through that. And then the note sheet had mentioned percentiles. So I'd like to quickly run through the idea of percentiles. I know that I mentioned it before, but percentiles sort data into 100 equal parts. That's why it's 100%, 10%, 23%. Any percent goes up to 100. The pth percentile is the value in the data that has about p% of the data value smaller than p, and 100 p minus p% values greater than p. So this is our example here. So when my daughter Lene was born, the doctor told me her length was in the 98.8th percentile. So what does that mean? That means she was as long as or longer than 98.8% of all the newborn girls. And then the flip side of that could be 1.2% of all newborn girls were longer. All right, so we have a little formula for that. So you're going to sort your data into increasing order, and then you're going to do your P over 100 divided by N. And then if L is a whole number, the pth percentile is the average of the number in the position L and L plus 1. If it's not a whole number, then the pth percentile is the number in the position of the next whole number. So we're going to round up. All right, so this is how this is going to work. The first thing we need to do is make sure that we put these numbers in order. So the smallest number I see is 5. Oh, just kidding, is 3. And then 5. 1, 2, 2 sixes, a 7, a 9, and another 9, a 10, an 11, a 12, a 14, and a 15. All right, so we sorted our data in order. Now, calculate the approximate value of the 55th percentile. So first of all, to find this one, we don't need to do that first step, but I think that's a good first step to do anyway. To do this one, the 55th percentile, that's this value, right? That's this formula up here, P over 100 times N. So P over 100 times N is going to be our percentile, 55, over 100, and N is the number in our data set. So this data set happens to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values in it. N is always our number of data. So 0.55 times 12 comes to 6.6. And then as we said before, you want to round up. And so we are going to the position of the next whole number higher than L. So that's going to be 7. So the approximate value of the 55th percentile is going to be 7. If we want to find the actual percentile rank of the number 7 in this data set, and these numbers aren't always going to coincide, but we're going to do this formula here, so number of value less than x. So if our number is 7, how many values are less than that? 1, 2, 3, 4. Right? These 4 right here show up. And then we're going to add 0.5 to it. That's our cushion. And we're going to divide that by the total number of values we had. And again, I'm using this formula up here, and then I'm going to multiply that by 100. So we're doing 4.5 divided by 12, and we're going to multiply that by 100, and we are getting 37.5%. I don't think too many of the problems that you're given deal with percentiles, but it is really good to have these formulas. And again, that's to work both ways, and those are for our specific data sets. So now you're going to practice with these tonight for homework.